So I just actually finished recording videos TG12 and TG13, so I hope that you found those fairly easy. So I'm going to go on that assumption as I'm doing this video for TG14. I'm going to tell you right now, TG14 is very, very difficult. Okay, this is, and I'm not trying, to scare you or anything like that. I'm just telling you this is very, very difficult. I have 3 examples for you today only. All right, this is just a continuation. We're actually in the same section in the book. This is just tough stuff. Okay, this is using all of the skills that we've learned in trig and some algebra skills and some quadratics and all kinds of stuff. We're going to throw all kinds of stuff at you today. So just be aware of that. Okay, slow it down, back it up, watch the examples more than once if you have to. Okay, this is tough stuff. All right, so we want to solve, again, the whole point of this lesson is to solve trig equations. All right, so we want to solve for x. That's what we want to know. What is x? All right, so what we're going to do is there's a few different techniques we're going to use. This one is simply factoring in its most basic form. Okay, we're going to solve this by getting a 0 on one side so that we can solve by factoring. You notice the square, that's what makes this more difficult. So I'm going to start this equation by subtracting tangent of x from both sides. Okay, so I have tan x cosine squared x minus tan x equals 0. Note, if you have strong algebra skills, this won't be as hard as if your algebra skills are kind of weak. All right. So now I have this and I want to solve this. I'm going to actually factor. Okay. I'm going to factor tan x out. So I have tan x out here, and I have cosine squared x minus 1 equals 0. Now, if you remember from factoring before, if I have 2 pieces like this, I can set them both equal to 0. Tan x equals 0. Cosine squared x minus 1 equals 0. I'm going to start with tan x. Okay. Now, we solve these as separate problems. Okay. You're going to end up with, in this case, we're going to end up with 3 x values. Okay. So we're going to solve this. First of all, tan x, we know that tan x is 0. The inverse of tan at 0 is 0. Okay. So tan x, so x, if I do tangent inverse of 0, okay, that's 0. We know that from our unit circle. So remember that these equations, this is the same thing from 12 and 13. This is no different. Okay, this is still plus k pi. So this one x equals 0 plus k pi. You can also just write k pi. You don't need the 0, but I'm putting it in there so you can see that. So that's one solution. Now I'm going to come over here to this one. Now this is a squared, so I'm going to solve this just a little bit differently. I'm going to add 1 to both sides, and I get cosine squared x equals 1. I'm going to take the square root of both sides, and I get cosine of x equals plus or minus 1. Again, from the unit circle. Okay, this is where if you're having trouble with knowing, hey, where did these numbers come from, go back to your unit circle and look at them. Okay, so the cosine of x equals 1 and negative 1 at 0 and pi. So I end up with x equals 0 plus 2k pi, and x equals pi plus 2k pi. So these are my 3 solutions to this problem. I want you to notice also there's a lot of overlap. Okay, k pi would actually hit every single one of our solutions. All right. Now this is, if you write it like this is perfectly acceptable. I'm not telling you don't have to, but I want you to notice that k pi, 2k pi. If you put 2k pi and not k pi, you wouldn't end up at all. Let me show you a picture. Okay. So here's pi, 2 pi, 3 pi, 4 pi. Okay. So k pi is going to hit. Okay. So k pi is going to hit this one, this one, this one, this one. Okay. So now let's look at 2 pi is going to hit this one and that one. Right. And then pi plus 2k pi is going to start at pi and hit every one. So you notice they all hit the same thing. All right, k pi would actually be a sufficient answer for this, but I want to see the work for the whole thing. Because most of them are not that nice or easy. Okay, so I know, again, this is difficult, and it's hard to know where to start. I think that's probably what your biggest struggle is going to be, is I look at a problem as Harrison and I go, I don't even know where to start. You start playing with it. I'm going to tell you that right now, that a lot of math is extending your ability to problem solve. Look at a problem and say, okay, What can I do? What skills can I use that I know that I might be able to use to solve this problem and go from there? So let's go on to another one. All right, this one. Okay, already we can see that this is going to be a hard problem. I'm going to tell you right now, we're going to use both factoring and some of our identities. Do we use identities? Yeah, we'll use identities to solve this problem. Okay, so a lot of people with this problem say, where do I start? Okay, because I have a cosine and I have a sine and I don't even know where to start. Obviously, we're trying to solve for x. Okay? Factoring is going to play a big role in this because it has a square. It would be much easier to factor if all of my units were the same. So if you remember correctly, cosine squared x is the same thing as 1 minus sine squared x. Okay? In fact, when I was creating the notes for these, I hauled out my little charts that we used before so that I can make sure I remember these rules precisely. Okay, so go back to those charts, go back to those things if you need to. It won't use a lot of complicated ones, they'll be the basics. So I'm going to rewrite this now as negative 10, 1 minus sine squared x, minus 3 sine x, plus 9 equals 0. Okay, then I'm going to simplify. Negative 10 plus 10 sine squared x minus 3 sine x plus 9 equals 0. Okay, simplify just a little bit more. 10 sine squared x minus 3 sine x minus 1 equals 0. Okay, now I have quadratic equation. Yeah, okay, there's signs in there, no need to freak out, okay? So, but I have a quadratic equation. I can solve this using, you can use a quadratic formula. We're actually going to do that next, but this one I can solve by factoring. So, if you remember your factoring skills, okay, I have a number in front of the sine squared, I have a number here, I'm going to multiply them together. I'm going to use the AC method. If you have other methods, by all means use them. We should get the same answer if your method is correct. So this is negative 1 times 10 gives me a negative 10. What adds together to give me negative 10? Multiplies together to give me negative 10. What adds together to give me negative 3? That's going to give me a negative 2. Sorry, wrong way. Negative 5, positive 2. Now I'm going to rewrite 10 sine squared x minus 5 sine x plus 2 sine x minus 1. I'm going to group. And I end up with, I factor out a 5 sine x. And I'm left with 2 sine x minus 1 plus 2 sine x minus 1. Again, grouping 5 sine x plus 1 times 2 sine x minus 1. Alrighty. Woo! And I'm not done yet. Now I have to solve. Okay? I have 2 equations. I'm going to solve both of them. You will end up with 4 solutions. Okay? Because we know for each one we have 2 solutions for each sine. We're going to have 2 solutions, and we have 2 sine equations. So we're going to end up with 4 solutions. So I need to actually give myself some space. See if I can do this. Now, I have 5 sine x plus 1 equals 0. I'm going to solve that. I end up with sine x equals negative 1/5. I do the inverse. Okay. And I come up with 0.201 plus 2k pi and 0.2. Now remember the second solution is pi minus that. So 294 plus 2k pi. I left out a step, okay? I said, I know that my first solution is this, that's calculator work. Then I do pi minus that to get 2.94 plus 2k pi for that. That's the first half. Second half, right here, 2 sine x minus 1 equals 0. I add 1 to both sides. I end up with sine x equals 1/2. Okay, now I should know that, right? Okay, sine of x is pi over 6. So I end up with pi over 6 plus 2k pi and k pi minus that, 5 pi over 6 plus plus 2k pi. Also, and you could know that more than one way, you could know that sine is positive in both the first and second quadrant. Second quadrant is 5 pi over 6. Okay, or you can do the pi minus. It'll give you the same thing. So I have 4 solutions, okay, for this equation. Remember when we were graphing? Okay, that means that if I was graphing in my 2 pi, I would end up crossing 1, 2, 3, 4 ways. Okay, I'm crossing 4 places within the 2 pi. Okay, so that's my solutions there. Let's go on to last example. Okay, I hope I haven't overwhelmed you too much again, because I realize that you look at this and you're like, I don't even know where to start. Okay, I'm hoping that by, again, these 3 examples that I give you some skills to know where to start. So let's go on to the next one. Last one that I'm going to do for you today. Okay, solve secant squared x plus 5 tangent x equals negative 2. Okay, the very first thing I need to do is I need to look at the fact that I have secant squared and a tangent, and I do not want those in there together. So I'm going to change that secant squared to tangent squared plus 1. All right, and I can do that because I know from my identities that I can do this. So I'm going to change this to tangent squared x plus 1 plus 5 tangent x. Okay, and I'm going to do one more step here. I'm going to move this 2 over here. Plus 2 equals 0. Okay, simplify really quick. Tangent squared x plus 5 tangent x plus 3 equals 0. Okay, now, a lot of you will look at this and you will say, oh, hey, how can I do this? How can I factor it? It's not factorable. But we can still solve it using the quadratic equation, the quadratic formula. So I think it's kind of funny, here we are using quadratic formula equations in trig. So that makes me excited. I know it probably doesn't make you excited though. Alright, so here we go. We're going to use the quadratic formula. And we're going to say not x, but tangent of x equals negative b plus or minus the square root of b squared. I'm just going to go ahead and write that as 25. Minus 4ac all over 2a. Okay? Now, you should be able to do this in a calculator. I'm not going to go into that part of it, okay? I did set up the quadratic formula for you. But we're going to end up with the tangent of x equals, okay, again, from my, just lost my train of thought. Okay, from my calculator. I did this in a calculator. I did positive, I did negative. I got negative 0.6972 and negative 4.3028. Okay, not done yet. Okay, I have to find the inverse of both of these. Now, remember, the nice thing with tangent is there's only one equation for both, or one solution for both. So I will have 2 solutions because I have 2 solutions starting from the problem itself. But I won't have to find more than one solution for each one. So I take the inverse, 0.697, and I end up with negative 0.6088. Remember, tangents plus k pi, and inverse of negative 4.3028 equals negative 1.34324 plus k pi. All right, and that is it for the notes on this. Okay, now let's have a bit of a chat, okay? Now I realize that we're probably going to get out, but I wanted to do this anyway. You'll notice on Edmodo I did put a homework assignment on there. However, I have every intention of spending tomorrow's class period, or whenever I see you again, if this is over a long period, a day or 2, the next class period that we have together, of actually doing this homework. Okay, I recognize that this is hard and this is different. Okay, some of you are going to say, no, Ms. Hurst, this was easy. Okay, and I love it when people say that, but in my opinion, this is more difficult. So I wanted you to watch the video at home. I wanted you to go through the video at home so that you can come to class tomorrow, you can pull out your book, and you can start working on the problems. So the intent is to actually do the problems in class. Don't feel like you need to start on them right now. I mean, if you feel like you want to try 1 or 2, go right ahead. But honestly, we're going to spend the majority of it, in fact, most of the class period tomorrow, working on this. So, so you don't have to do your homework. This was your homework. Just watch the video. So, thank you.